Good morning, students. Hope all of you are doing well. Today I am going to start a new chapter number 6, heat transfer. So at first I start that chapter, we will recall the previous things whatever which are related with this chapter. Okay. So do you remember this picture? Do you remember what is this? What is this? This is a interconversion of three states. So in our nature we can find matter in three different states. First of all is the solid, liquid and gas. So what is melting? Melting is a process of conversion when that solid is melts and is changes to liquid state. That is melting. And the freezing is the reverse of that melting, means it changes from liquid state to solid state. So same way, when that boiling is a process of conversion when that liquids is changes to changed to a gas. So at a particular temperature on heating, and condensation is the opposite of the boiling. In condensation is that in the process of conversion when the gas is changes into liquid at a particular temperature on cooling. So these are that solid, liquid and gas are interchanged to each other, and then how that is actually called that process is called sometimes is called when the solid to liquid is melting, liquid to solid is freezing, liquid to gas is boiling, and gas to liquid is condensation. And how at a particular temperature or cooling or heating. So that is actually, you can understand, that is actually heat is related on that. Okay, because that liquid is changes to gas is not possible. It's only just you put a cup of water and it's just changes to water. No, at a particular temperature and on heating. So heating and cooling. So what is this actually? That is temperature. Okay, so that's actually the temperature that we can see that object is a hot or the object is cold. Okay, so when the glass filled with water is felt in a room for a day, so what you will notice that the level of the water decreases. So where does the water goes? It is converted into its vapor. So even though it is at room temperature, in this process the same as boiling. So you see here that glass filled with water is left in a room and for a day. So that is, but that even though it is at room temperature, that time also is vapors, that is converted into its vapor. And what is the process? The same as the boiling, wherein the liquid gets converted to its gaseous state. So how you see that the liquid is changes to gaseous state, and what is this called is boiling. But that is also called evaporation. But that is the differences between the boiling and evaporation. That things I will discuss afterwards. So wherein the liquid gets converted to the gaseous state, so that is, we know that is called the boiling. So although the end result in the above process is the same as that in boiling, it is altogether a different process than boiling. So this process is called evaporation. So boiling, what is the boiling? In boiling also the liquid gets converted to gaseous state at a particular temperature on heating. But when that glass is in room temperature, how that when you leave the glass filled with water, and how it's converted to vapor even though it is at room temperature. So that is the same as boiling, but that is not called the boiling. What is this called? That is a evaporation. This process is called evaporation. So let us about these two processes. So boiling and evaporation we will learn in detail. So you do remember the first chapter of this book, whenever I discuss the matter. So that chapter you already learned what is the matter and what is the atoms, molecules, and the three states of matter, solid, liquid, gas, and what is the characteristics, and what is that what is the interconversion of solid, liquid and gas. So those things already you have learned, and that time also you have learned what is the boiling, what is the boiling point, what is the vaporization. Vaporization and boiling are both are the same things, okay. And the what is the evaporation. So that's things already already you learned from that beginning of this of this book, and that is the first chapter, I think. So during this process all the molecules, so you see here that vaporization, what is the, and boiling, what is this. So you see here that solid, liquid and gas, what is the boiling. It is the boiling or vaporization is the same things. You can say it is a boiling, and also you can say this process called is vaporization. So the process by which a liquid changes into its gaseous state at some fixed temperature, or you can say at a particular temperature, by absorbing of heat energy, is known as vaporization or boiling. So the process by which a liquid changes into gaseous state at a particular temperature on heating, so mean is absorbing heat energy, means it's we are giving the heat, and that liquid actually is absorb the heat energy, and that's why it changes into gaseous state, is known as vaporization or boiling. For example, water changes into steam at 100 degrees centigrade on heating. So now you can understand what is the boiling and vaporization. So boiling and vaporization is the process by which a liquid changes into gaseous state at a particular temperature by absorbing the heat energy, is known as vaporization or boiling. For example, water changes into steam at 100 degrees centigrade on heating. Now is the question is that what is the boiling point. So the boiling of a pure liquid occurs at a fixed temperature is called boiling point. During this process, all the molecules of the liquid are involved in the process, hence boiling occurs in the whole volume of the liquid. So that whenever that liquid I am taking, and when we are providing some heat, so that time, so what will happen, it will start to boil, and that it will changes into steam at 100 degrees centigrade on heating. So what is the boiling point? Boiling point is that point, that is a fixed temperature. When that boiling of the pure liquid occurs, means that the whole liquid will start to boil, so at fixed temperature, that is called the boiling point, means it start to boil. And during this process, all the molecules of the liquids are they are involved in this process, and the boiling occurs in the whole volume of the liquid. But what is evaporation? So evaporation, many a time a liquid changes into its vapor state even below its boiling point. So below its boiling point also the liquid changes into its vapor state. For instance, wet clothes hang out in the sun, mopped floor and wet hair dry up with time. So the change of a substance from its liquid state to its gaseous state at any temperature below its boiling point. So that is the difference, is that boiling and the evaporation is that in evaporation actually that process will be occur, but that will be below its boiling point at any temperature. But in boiling it is possible at a particular temperature. But in evaporation will occur at any temperature but below its boiling point. In a liquid, the molecules are in constant random motion, because we know that molecules are in a constant random motion. The speed of these molecules keeps changing due to their collision with other molecules. When they are collide to each other, they will change their speed, and if the molecules near the surface of the liquid gain sufficient energy, they will escape and become vapor. Okay, So whose of the molecules is near the surface of the liquid, that molecules actually gain the sufficient energy to escape and they become a vapor. So when the temperature of the liquid increases, the average kinetic energy of the molecules increases. So already we have learned that from the chapter of matter. So there we know that if that kinetic energy is proportional to temperature. So means when the temperature will increase, the average kinetic energy of the molecules will be increases. Due to this, a large proportion of molecules will have sufficient energy to escape from the surface of the liquid. Hence, the rate of evaporation increases with the increase in temperature. So, you see here that when the temperature increases, so means the rate of evaporation also increases, because that the temperature of liquid increases and that the average kinetic energy of the molecules will be increases. So due to this, large proportion of the molecules have sufficient energy. So what will happen? When they gain the sufficient energy, they will escape out and they become a vapor. So escape out from the surface of the liquid, so that the rate of evaporation will be increases. So what is the result of this? So means the rate of evaporation increases with the increase in temperature. So what is the effects of evaporation? That drying of wet. So drying of wet cloths occurs because of the evaporation of water from their surface. Water stored in an earthen pot seeps out on the surface of the pot through its fine pores and evaporates. This lowers the temperature of the water in the pot. Sweat absorbs heat from your body to evaporate. This helps to cool down your body during summer. So you see here, so when the temperature of the liquid increases, the average kinetic energy of the molecules is also increases. So when the kinetic energy is increases, so what will happen? The large proportion of the molecules, they have the sufficient energy. They gain the sufficient energy to escape out from the surface of the liquid, and what will happen means they escape out and they become a vapor. So hence the rate of evaporation increases with the increase in temperature. So what is the effect of evaporation? So you know that during the summer time, when that sweat is absorbed heat from your body to evaporate, so this helps, what helps you will get to, this helps to cool down your body during summer. And water stored in the earthen pot seeps out on the surface of the pot through its fine pores and evaporates. This lowers the temperature of the water in the pot. And the drying of wet cloths occurs because of the evaporation of water from their surface. So now is the things is that what is the difference between evaporation and boiling? So it is easy to get confused between evaporation and boiling, because those are that is actually the same process, but there is some very small difference. So because the same things is here, so also that is a process of conversion from liquid to gas. These things is same for both the case, but is the difference is there, it is that evaporation is a continuous process wherein a liquid absorbs heat energy from the surroundings and changes into vapor, and boiling is a process in which a liquid changes into its vapor state at a specific temperature, means the boiling point, by absorbing external heat. So what is the difference between evaporation and boiling? The first difference is that evaporation occurs at all temperatures, but boiling occurs only at the boiling point of a liquid. Evaporation is a slow and silent process, but boiling is a brisk and violent process. Evaporation occurs only at the surface of the liquid, and boiling occurs over the entire mass of the liquid. And evaporation causes cooling, and boiling does not cause cooling. Okay, so these are the difference between evaporation and boiling. So now you see the check your progress. There have some question. The boiling causes cooling. So is it true? No, it is not true. So this statement is false. So you write down here, it is false statement. So who causes cooling? So the answer will be evaporation. Now question number 2. Wet cloths dry because the water in them boils into its vapor state. No, actually that wet cloths dry because the water in them. So the wet cloths dry because of the evaporation of water from their surface. So that answer will be false. So because of the evaporation, so because of the evaporation from their surface, this statement is also false. So boiling occurs in the whole volume of a liquid, whereas the evaporation occurs only at the surface of the liquid. This statement is true. And the number 4, water evaporates at all temperatures. So yes, the water evaporates at all temperatures. This statement is also true. Yes, the water evaporates at all temperatures. And the question number 2, the wet cloths dry because the water in them boils to its vapor state. So this statement is false. That wet cloths dry because of the evaporation of water from their surface. Now you see the thermal expansion. The most substances increase in their dimensions when they are heated, and the expansion produced in matter due to the absorption of heat energy is called the thermal expansion. So that is actually the when the the expansion is produced in a matter due to the absorption of heat energy. When the matter is absorbed heat energy, so they will expand. So you know that matter are 3 states: solid, liquid and gas. So their expansion is not the same. So what type of expansion we will see, that things we will discuss in this part. So most substances increase in their dimension when they are heated. The expansion produced in matter due to the absorption of heat energy is called thermal expansion. So when a substance is heated, the kinetic energy of its molecule will be increases, and the molecules start moving from vigorously. As a result, the distance between the molecules increases. So distance between the molecules increases, so means intermolecular space is increases, and the substance expands. So in solid, that molecules are closely packed, are held together firmly. So you know that in solid actually the intermolecular space is very small, so that's why intermolecular force of attraction is very large. So that's why they are closely packed and are held together firmly. So solids expand a little on heating. In liquids, molecules are loosely packed because in liquids the intermolecular space is more on the solids and but less in less than gas. So that's why it is loosely packed, and they can free space in comparison to solid, because in solid actually the intermolecular space is very negligible, and so that's why liquids molecules are loosely packed according to the solid. And on heating, the distance between the molecules increases, and so the liquids expand more than the solids on heating. But in gas actually the molecules are free to move because the intermolecular space is large. So that's why intermolecular force of attraction is almost zero. So that's why gases expand the most on heating. So whenever you compare the 3 states, solid, liquid, gas, so on heating the gas will expand more than liquid, at the last is solid. So the types of thermal expansion, there are 3 types of thermal expansion. The namely are linear expansion, superficial expansion and cubical expansion. So what type of expansion we will see in which state, that things we will learn here. So that linear expansion, the increase in length of a solid on heating is called linear expansion. Linear expansion depends on the following factors. So first of all, the original length of the solid. A longer rod of a metal expands more than a smaller rod of the same metal when the heated for the same amount of time. So who have a longer rod of a metal expands more than a smaller rod of the same metal when heated for the same amount of time. So when you heated two rods, one is the longer one is the smaller one, and at both cases, whenever we think about the certain time, we bind it, and then for both the cases we will same amount of time, and we give the heat. So that time we can find out the longer rod of a metal expand more than the smaller rod of the same metal. And now is the second point is the increase in temperature when two rods of the same metal having the same length are heated to different temperatures. The rod heated to a higher temperature expands more than the one heated to a lower temperature. And number third is the nature of the solid. So when two rods of different metals having the same length are heated to the same temperature, one rod expands more than the other depending on the nature of the metal. Okay, so these are the three points. Factors is depends. The linear expansion is depends on the following three factors. And the next is superficial expansion. Superficial expansion is the expansion in area of a solid on heating is called superficial expansion. For example, the area of a plate or a sheet of metal increases on heating. Okay. And cubical expansion is the expansion in volume of a solid, liquid or gas on heating is called cubical expansion. So you see here that that linear expansion is, you see that is actually, we can see that is in solid, and superficial expansion expands in area of a solid, that's also we can see in superficial expansion, we can see in solid also. But in cubical expansion, so that is actually the solid, liquid and gas, both volume will be expand on heating. So that's why it is a cubical expansion. And the thermal expansion of solid. So different substances have identical dimension when heated through the same range of temperature expand by different amounts. For example, brass expands 1.5 times more than steel, and aluminium expands twice as much as steel. So let us perform an activity to observe the difference in expansion of different solids. So you see here then activity 2, that is see this, the blue one is made up of iron and the red one is made up of brass, and at room temperature they see this how they are looks like. But whenever you give the heat, so whenever they are heated, so what we will see, so we will see that brass expands 1.5 times more than the steel, and aluminium expands. So you see in this case that is iron and brass, so which one is more expand? So you see that the strip acquires a curved shape, so such that the brass is on the outer side of the curve, indicating that the brass expands more than the iron on heating. So you see here that two substance we have taken, the iron and brass. So at room temperature the shape is like that, but whenever we are applying heat, that time you see the strips acquires a curved shape. So see this looks like a curved shape, and such that the brass is on the outer, so brass is on the outer side of the curve, and indicating that the brass expands more than iron on heating. So we can, from this example we can understand different solids expand by different amounts on heating. Okay. And see here the first activity to demonstrate the thermal expansion in solids by Gravi-Sandys ring and ball experiment. So you see that in the first case, when before heating, so before heating how that through the ring the ball is here. So whenever you give the heat, so when the ball is heated, it does not pass through the ring because it expands on heating. When the ball is cooled, it easily passes through the ring and it regains its original size. So solid expand on heating. So one thing you see there, that first of all you take the iron ball and the iron ring such that the ball should just pass through the stand and hit the ball, and then you try passing the ball through the ring. What do you observe? So you observe when when the ball is hit, it that time it does not pass through the ring because it expands on hitting. When the ball is cooled, it easily passes through the ring and it regains its original size. So means we can, what conclusion you will get? The solid expand on heating. So hope student you understood, and next day I will discuss the examples and application of thermal expansion of solid. So thank you students, hope you understand. Take care, bye, have a good day, bye bye.